We're going to go over Unit 1, Lesson 10 questions real fast, and then we'll talk about when your Unit 2 is finished. From what I see, not a lot's been done, so I don't want to get on that. Make sure when we finish this that you're working on that as well. A couple people have done a lot, not many people at all, though. All right. So it says the following histogram shows the relative frequency of the heights recorded to the nearest inch of population of women. The mean of the population is 64.97 inches and the standard deviation is 2.66 inches. One woman from the population will be selected at random. Based on the histogram, there he is. Based on the histogram, what is the probability that the selected woman will have a height of at least 67 inches? So we want the probability that the height is at least, so greater than or equal to 67, okay? Because it says greater than or equal to, you're using all of these. So all we're doing is adding them up. 0.11, 0.07, 0.05, 0.02, plus 0.01, plus 0.01, which gave us 0.27. And I think most of you got that correct. And that was it. This? No, just this. I just did this to show you. I always set it up like that. That's just more for me to be a visual and for you to understand where those numbers came from. All right. So what is the area of the bar corresponding to a height of 67 inches in the graph? And what does the area represent in terms of probability? So remember when you do this, the bar for 67 is 0.11, but it asked for area. So you need to make sure that you multiply it by the width as well. It's only 1 unit. So be careful about that. If they gave you like 67 to 68 or something like that, you would have to divide it by 2. I mean, sorry, multiply it by 2. Y'all understand what I'm saying? So watch that area. Your face, I don't like it. It just wants to know the area. That's it. You guys did it. You did the 0.11, which was perfect. The only thing I'm telling you is if it's one where you have, there's one question in here where your category goes from like 1 to 4. Y'all see what I'm saying? So if it's 1 to 4, you would have to multiply this by 4 because the width is 4. But on this one, it's just 1 because it's just one number, 68, 67, whatever, which gives you that 0.11. So I just wanted to show you, almost everybody got this question right if they tried it. So there it is. And what does it mean in the, what does that area represent in terms of probability? It's the probability of what? Who having a height? What kind of woman? Randomly selected woman. Having a height equal to 67. That's it. Okay, so nothing crazy. Just make sure that you put that, the probability of a randomly selected woman. All right, C says the histogram displays a discrete probability model for height. However, height is often considered a continuous variable that follows a normal model. Consider a normal model that uses the mean and standard deviation of the population of women as its parameters. Use a normal model and the relationship between area and relative frequency to find the probability that a randomly selected woman will have a height of at least 67 inches and share your work. Does your answer in part C1 match your answer in part A? If not, give a reason for why it might be different. So we're going to do the same thing where the probability of the height is at least 67. But this time it's telling you to use the normal curve with a mean of 64.97 and the standard deviation of 2.66. Those numbers came from the problem. So right there. Is that good? All right, so how do I find the probability given the mean and the standard deviation? What do I use? Don't think too hard. You know how to do this. Normal CDF. All right, I want greater than or equal to 67. So what is my lower? My upper? And then your mean was 64.97. Give me a second. and your standard deviation was 2.66. Sorry, I'm squishing it up. That gives you 0.2226. Any questions on that? So this one was 0.226. Our other one was 0.27. So it says, does your answer in part C1 match your answer in part A? If not, give a reason for why the answers might be different. So this one is actually less than part A, and why is because there is less area in the tails. Sorry, can't write today. Of the normal curve. And that's it. So remember, when we drew it, I'm gonna drop it up here. They try to make it match more like this. So there's less area in the tail and more towards the middle. Does that make sense? Everybody understand that? All right. Let the random variable H represent the height of a woman in the population whose height is less than 60, represents the probability of randomly selected one with height less than 60 inches. Based on the information given, the probability can be found using either the discrete model or the normal model. The discrete model is the actual bar graph, okay? Give an example of a probability of H that can be found using the discrete model, but not the normal model, and explain why. Explain why. So on this would be any whole number value. It doesn't matter what you would have given me because all of them would work because your discrete shows you exact areas. And that's what it was looking for, was the area. We'll look for the area under the curve. You can't do area with a normal curve. That's the only difference, okay? So on this one, give an example of a probability that can be found using the normal model, but not the discrete. The discrete is all whole numbers. So in the normal, any decimal or fractional number, like 63.5, 63 and a half inches. The discrete model only shows 63 and 64. We can't pick up 63.5. Does that make sense? That's all it's asking for. Got it? And they probably would want you to write it like this. Okay, so just understand that. All right, so that's all of question 3. Any questions about that one? Pretty simple. Okay. Your next one, you have a frequency table, and this is the one I was talking about, has 0 to not including 5. So 0 to less than 5 would be 4. So the length or the width of the bar would be 4, where the height would be a little bit different. Okay. All right. So if we make our histogram, I made it, let me try to close it up right here. I made it like this: 0 to less than 5, 5 to less than 10, 10 to less than 15, 15 to less than 20. It's the amounts, the frequency goes on the side. And then I put the numbers up here, 8, 14, 25, 27, 17, and 5, because not 17, 12 and 5, because then it asks you for the median. The median, remember, is in the middle. So over here, I added these up. There were 22 right here in this area. There is 17 here, 18, 19, 20, 21, 22. So that leaves 20 here and 25. So your median is going to be within this bar. You can literally do it that way. Or you can say there is this many total. The middle is the, I think it's 46 in this one, 46 term, which would fall between 10 and less than 15. So what would be the value of your median? What would be the value of your median? That is this part. If it's this bar, what would be the value of your median? Between 10 and? Mm-hmm. Between 10 and 15, but make sure that you don't include 15, okay? It would have taken any value that you chose. This is the best answer. Does everybody understand that? So what they're looking for is a number between 10 and 15, not including 15, and this is the best answer to get right here. Don't give a specific value, just give a range of values, and then just make sure they would have counted off for you not putting that right there. Okay, if you would have said 10 to 14, that would have been a problem as well. Got it? All right. Describe the shape of the distribution of amounts. You guys did that fine. Unimodal, roughly symmetric, no outliers. Your center is somewhere between 10 and less than 15. Very good. Your spread is blah, blah. So anytime it says describe, make sure you do all of those. All right. That was it for that question. Number 7. Kathy and her brother Clay recently ran a local marathon. The distribution of finishing time for women was approximately normal with a mean of 2:59 and standard deviation of 32. The distribution for men was mean 2:42 and standard deviation 29. The finishing time for Clay was 2:89 minutes. Calculate and interpret the standardized score for Clay's marathon. So remember, the standardized score is the Z-score. You're going to do his value, which is 289, minus the mean. Make sure you do the mean of the men. This was women. Men was 242 over the standard deviation of men, which was 29, and gave a value of 1.62. I think most of you that did this got it with squeaky there. Yeah. Got it right. Is everybody good? All right. So then it says the finishing time for Kathy was 2:72 minutes. What proportion of women who ran the marathon had a finishing time less than Kathy's? So again, just for me, it said a finishing time less than Kathy's. So finish less than 2:72. The way we're going to do that, it said it was normal, so I'm going to use normal CDF. If we want less than 2:72, what's our lowest? What's our highest? Remember, she's a woman, so what was her mean? And standard deviation, which gives 0.66. So 66%. You can leave it as 0.66. You don't have to make it 66%. Okay, they're not looking for that. All right, so part C says the standard deviation of finishing time is greater for women than for men. What does this indicate about the finishing times of the women who ran the marathon compared to the finishing times of the men? So there was more variation in the women. So their times were further from the mean. Than men. I'll move it up in just a minute. And why do we talk about that? Because it said the standard deviation. We weren't talking about the means anymore. So there was more variation in the women. Their times were further from the mean. That's it. That's all they were looking for. And now we're on the last one. I told you it wouldn't take long. So very good. All right. 9. Also pretty simple. The distribution of pH levels for all community swimming pools in a large country is in a large county is approximately normal with a mean of 7.5 and a standard deviation of 0.2. According to swimming pool studies, the safest pH levels for water in swimming pools are between 7.2 and 7.8. The distribution of pH levels, one community swimming pool in the county will be selected at random. What's the probability the selected pool has a pH level that is not considered safe? So what I did is I found the safe and then subtracted it from 100 instead of doing 2 different calculations, if that makes sense. So I went ahead and did 7.2 less than or equal to X less than or equal to 7.8. And then once I found that, because that's the safe, I subtracted that from 100 or the 1 to find out what was unsafe. So if anything less than 7.2, you could have done that and added it to anything greater than 7.8. Does that make sense? So whichever way you did it is perfectly fine. She just got that. All right. So when I did this, I did normal CDF. My low is 7.2. My high is 7.8. My mean is 7.5. And my standard deviation is 0.2. And then I subtracted that from 1 to get my unsafe. And when I subtracted it from 1, I got 0.1336. Overall, most of you got that number. However you got it is perfectly fine. It obviously worked whichever way you did it. Okay. Some of you didn't show work. You just put the number, so I don't know how you got it. Does that make sense? Either way works. Okay. All right. The county health inspector will select a random sample of 4 community swimming pools in the country, or I keep saying country, sorry, in the county to investigate the pH levels. So this time we're doing 4. Describe the sampling distribution of the sampling mean for sample size 4. What they were looking here was the mean of the sample and the standard deviation of the sample. So your mean, remember, is the same as whatever your normal mean is, which was 7.5. When we do the sample standard deviation, we have to do the standard deviation over the square root of n. So that's the one that most people did not get. Y'all are okay with the mean here, or you just didn't really answer the question at all. You said it was like approximately normal, blah, blah. You don't have the distribution, so you don't know that. So what they were looking for was the center and the spread. So your standard deviation was 0.2. We had 4 pools. That would give us a new standard deviation of 0.1. Those are the 2 things that they were looking for. Okay, very good. All right. Consider the situation in which the health inspector finds the sample mean of the 4 pools to be outside the pH levels. As a result, the inspector declares that the population mean is not 7.5. However, if the population mean really is 7.5, the inspector will have made an error. Such an error is called a type 1 error. Find the probability that the inspector will make a type 1 error with a sample of 4 pools and show your work. All right. So the way that I did it was using the standard deviation and the mean that they gave us. So this is what I did. This is not what they did on the answer key. I'll show you what the answer key did. I did normal CDF. Your normal range was 7.2 to 7.8. Where did I get this picture's not 7.5, population is really 7.5. All right, so I use 7.2 as our mean and our standard deviation as 0.2. And we got 0.4986. And I did the same thing using my 7.8 as the mean. Okay, which gives me 0.4986 as well. These 2 combined are 0.9973, 7.9973. And then I subtracted that from 1 and got my 0.00269. Give me a minute and I'll show you what the answer key showed. Like this? She does not.
How many does she have?
1 or 2.
There's some in the closet, but who would put on those?
The skinny ones?
Yeah.
How many she got in there? How many she got total? She does not have a class set because those are the rest to complete her class set.
There's some in the closet, but I don't know if they're in there. So there weren't in their body when I left.
Oh, I don't know. Maybe she asked sub to. All right. So let me show you what they did. I think they did more work than what I did, so I didn't do it that way. All right, so they said the sampling distribution is normally distributed with a mean of 7.5 and a standard deviation of 0.1. A type 1 error will occur for the sample mean less than 7.2 and greater than 7.8. Okay, why did I choose 7.2 and 7.8 for my means? Because what is a type 1 error? What is a type 1 error?
Probability that failure is good. Well,
So we say that we're swimming in safe, but we're not. Okay, I'm okay with that. All right, so I chose 7.2 and 7.8 because we want the outsides. Does that make sense? So that's what we were doing. So they found the z-scores, instead of just doing it normal CDF, they found the z-scores to be -3 and 3. So based on the normal table, you're going to go greater than 3, which would, what I did, greater than 7.8, or you would go less than 7.2. When you add those two up, it gives you 0.027. So 0.0027, which is the probability of the type 1 error. So I think you guys were doing it right. You just weren't using maybe the right numbers. So they normalized them and used z-scores, and I did not. I just used normal CDF to make it a little bit easier. So it's whatever you want to do. Got it? All right. Any questions on quiz 10? That is it. All right. So I want at least the multiple choice finished by the end of the day today, not the end of the class period, before we come back tomorrow for class period. Got it? So multiple choice, I can hold off on the free response. I would go ahead and try to get it done though, just so you don't have anything. I will start making the unit 3 ones tomorrow during planning period. So you guys will have those at the beginning of class tomorrow. Yes, I want the progress check done. Yes. And then, like I said, free response, you can finish it up. I will start going over it on Thursday. So I will give you a little extra time to do the free response. But I want it done Wednesday at midnight so that we can go over it Thursday. I don't want to wait. I want to have it graded by the time you come to class on Thursday. Does that make sense? Everybody good? So all multiple choice, including the progress check, is due by the beginning of class tomorrow, and then your free response is not due till Thursday, and unit 3 will be started open tomorrow. I hope all that is clear. Is everybody good? All right, Zoomers, you're free to go work on your multiple choice.
Hey, so we're on the way home and it says we'll be in Raleigh at 3:13. So
Yeah, you're not gonna make it.
no, if I get there, it's gonna be really late and I will be in
Yeah,
like
no, you're fine. You're fine.
Okay. All right. Thank you.
No worries.